Hello, my darlings. So today we're going to learn the shortcuts and the basic power derivative rules. This will help you so you do not have to use the definition of derivative unless specifically told to use it. So our first rule is the power rule, and you'll see it's written in 3 different ways, okay? If you take a look, this is the rule. And then it's written 2 other ways, okay? But all you need is that first part. If the function f of x is x raised to an exponent, that's a number, then the derivative is you bring down that exponent, keep the x, and lower the exponent by 1. If the name of the function is y, we know that the name of the derivative is dy dx, but it's the same rule. Bring down the exponent, keep the x, subtract 1. Now the third way to write it is the derivative with respect to x of x to the n, and then it's the same rule. Bring down the exponent n, keep the base x, subtract 1 from the exponent. So for instance, if we have f of x is x to the 5th, we're going to bring down the 5, keep the x, and our new exponent, 5 minus 1 is 4. Ta-da! You've done the derivative. The next rule is the constant power rule. So again, we really just need this first box. I'm giving you the 3 notations because it really depends on what textbook you're using and your professor, which notation you're going to see in future calculus classes, okay? Now, the constant power rule says if there's a number in front of the x that's raised to an exponent, you're just going to multiply that number by the exponent, and you're still going to decrease the exponent by 1. And if the name of the function is y, then its derivative is dy dx. So if we have f of x is 3x squared, we keep the 3, we're going to bring down the 2, keep the x, subtract 1, so our new exponent is 1. That means that our derivative is 3 times 2 is 6x. Now, do you have to show that middle step? Absolutely not. You can definitely go from f of x is 3x squared and say that 2 times 3 is 6x. Our new exponent is 1. We're done. Absolutely. Next comes the constant rule. Now, the constant rule says that if we have a function which equals a constant number, in this case we're using c to represent the number, but it might be f of x is 5, it might be f of x is 100, it doesn't matter, but that the derivative is 0. Now remember, a constant function y equals c, if you think about that graph, that's a horizontal line with a height at c. What is the slope of that line? All horizontal lines have slope of 0. That's why the derivative is 0. So there it's graphically, and we can actually prove that analytically. And I know you're scared because I said the word proof, but I promise this is an easy proof. If we let f of x equals c, here's our definition of derivative. F prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're going to have the limit as h approaches 0 of, my denominator is h, we're going to have f of x plus h minus f of x we know is c, but what is f of x plus h? It doesn't matter what we're plugging into f, we're always going to get the answer c, which means f of x plus h is the same as f of x, so that when we subtract them, our numerator is 0, which means we're taking the limit at h heads to 0 of 0. That's a constant, and a limit of a constant is that constant, and we are done with the proof. So now if I was to ask you if f of x is 5, then f prime of x is 0. If f of x is negative 10, then f prime of x is 0. If f of x is e, now remember e, that's an irrational number, just like pi. Remember, it's about 2.72. Oh yeah, it's 2.72. That's a number. So if I take the derivative, it is 0. That's it. Derivative of any number is 0. Let's just practice a couple. So if f of x is 4x to the 7, then f prime of x is going to be 7 times 4 is 28. Keep the x, but 7 minus 1 is 6. There's your derivative. Number 2, if f of x is negative 5, x to the negative 4th, then f prime of x is, well, we're going to have to do negative 4 times negative 5 is positive 20. Keep the x, but remember, negative 4 minus 1 is negative 5. So the exponent got smaller. If f of x is x to the 3.2, then f prime of x is x raised to the 3.2 minus 1 is 2.2. If f of x is negative x to the negative 11, then the derivative f of x is negative 11 times negative 1 is positive 11. Keep the x, but negative 11 minus 1 is negative 12. Awesome. All right, what about number 5? F of x is x to the negative 3/4. That means f prime of x is, bring down that exponent, negative 3/4 times x. Now remember, when you do negative 3/4 minus 1, you're going to rewrite that 1 with a denominator of 4. Keep your denominator. Negative 3 minus 4 is negative 7. So negative 7/4 is our new exponent. Now the next one, I don't see an exponent in f of x. F of x is the square root of x. But we know that the square root of x is x to what exponent? X to the 1/2. Very good. Which means that f prime of x is, bring down the exponent, times x. Now subtract. 1/2 minus 1 is negative 1/2. Now here's the thing that I'm going to tell you. If I don't give you negative or fractional exponents, so there's no negatives in the exponent and no fractions in the exponent, then your answer can't have negatives or fractions in the exponents, because there are going to be times where you have to do that and you have to be able to make the changes, and those are Algebra 1 changes. But we are going to, in our course, force you to make those changes certain times so that you practice those skills and that you have them. So that means we're not done. We need to rewrite this. A negative in the exponent tells me it's going to go in the denominator with the 2 from the 1/2, from this 1/2, and a 1/2 in the exponent. What does a 1/2 in the exponent mean? That means, right back here, that it's the square root of x. So f prime of x is 1 over 2 radical x. There is another rule I want to show you today, and that's the sum or difference rule. Really, all it means is if you're adding or subtracting two functions and you want the derivative, you take the derivative of each part. In other words, if we have f of x is x to the 4th plus x squared, then to find f prime of x, we take the derivative of x to the 4th, which is bring down the 4, keep the x, 4 minus 1 is 3, and then we're going to add the derivative of x squared. We're going to bring down the exponent 2, we're going to keep the base x, and 2 minus 1 is 1, but I don't have to write an exponent of 1, we know it's there. There it is. So you just take the derivative of each part. So here we go. Let's try B. So 8 times 3 is 24. Keep the x. 8 minus 1 is 7. Minus, we're going to have to do the 5 times the 2 is 10. Keep the x. But what's our new exponent? 5 minus 1 is 4. Plus. Now the exponent on this x is 1, and 1 times 6 is 6. What's the new exponent? 1 minus 1 is 0. But what is x to the 0? That's just 1, which means the derivative of 6x is just 6. Okay, we'll come back to that in a second. And then finally here, we have plus, what's the derivative of 1? 1 is a constant, which gives you 0. Another way to think about that constant rule, by the way, 1, that's really 1 times x raised to the 0. So when you bring the exponent down front, 0 times 1 is 0. And it doesn't matter that it's times x to the negative 1, because 0 times anything is still 0. Now, if we neaten this up a little bit, because we don't need these extras, we're going to have 24x to the 7th minus 10x to the 4th plus 6. Is it okay to go from here to here? Absolutely. But for the first time, we wanted to make sure you understand that the derivative of 6x is 6 and that the derivative of the 1 goes away. It's 0. Last thing to learn today, and it's not really that you're learning it. We already learned it in our previous unit, but it's coming back. So we already learned that the derivative of sine x is cosine x, right? Remember that? And we learned that the derivative of cosine x is negative sine x. So those two derivatives you're going to need to know for this unit because we're going to use that. We're going to use both of those derivatives, so you need to know that. And remember, the other things that are written here, it's just if the name of the function is y, then the derivative is dy dx. And also, in case it's written as the derivative with respect to x of sine x, you get cosine x. And the derivative with respect to x of cosine x, you're going to get negative sine x. If you prefer this notation to help you remember them because it's shorter, go for it. Whatever works for you. Now, if you have constants in the front of them, the constants come along for the ride here. So the derivative of 2 sine x is 2 times the derivative of sine x is cosine x minus 3 times the derivative of cosine x is negative sine x, but that needs to be simplified. F prime of x equals 2 cosine x, and a negative 3 times a negative sine x is plus 3 sine x. And here is where we would stop. Okay, a few problems to practice with. So the first one, f of x is 3x squared minus 4x plus 1. So our derivative, f prime of x, we do the 2 times 3 is 6, keep the x. 2 minus 1 is 1. I'm not going to write an exponent of 1 though. Minus, now the exponent on x is 1. 1 times 4 is just the 4. And the new exponent is 0, which means it's 1 and I don't need it. Plus, the derivative of 1 is 0. So here we go. Remember, that was 6x minus 4 times x to the 0. But that x to the 0 is 1, and 1 times negative 4 just leaves you with that negative 4. All right, now we have f of x is sine x plus cosine x. That means that f prime of x is going to be the derivative of sine x is cosine x plus the derivative of cosine x is negative sine x. So really that just becomes cosine x minus sine x. Nice. Now we get to number 3. Now my strong suggestion on number 3 is you need to rewrite the function before you take the derivative. So if you look at this, we have 3x to the 5th minus 5, but the square root of x is x to the 1/2 plus, now 7 over x is 7 times x to what exponent? It was over x to the first. What told us to put it in the denominator? A negative. So it's 7x to the negative 1. Now we can take the derivative, and we do 5 times 3 is 15. Keep the x. 5 minus 1 is 4. Minus, now 1/2 times 5 is 5/2 x. And now we're going to subtract 1 from the exponent. 1/2 minus 1 is negative 1/2. Now we're going to do negative 1 times 7. That's a negative 7. Keep the x. And negative 1 minus 1 is negative 2. Now notice I have fractions and negatives in my exponents, but I didn't give you any of those in the original function, which means you can't give that to me as your answer. So we need to rewrite this function. 15x to the 4th is fine. Minus, I have 5/2. The negative in the exponent is going to put my x in the denominator, and the fraction 1/2 in the exponent tells me to take the square root. Minus 7. Now notice 7 is staying in the numerator because only the x is raised to negative 2. So only the x is moving to the denominator. Be careful of that, guys. It's your Algebra 1 that's going to get you. Be very, very careful. Let's try another one. So number 4, f of x is negative 2x to the negative 3 plus 3 times the square root of x. That's really x to the 1/2. Now we can take the derivative. Negative 3 times negative 2 is going to be positive 6x. Negative 3 minus 1 is negative 4. Then we're going to have plus 1/2 times 3 is 3/2 x. But our new exponent, 1/2 minus 1 is negative 1/2. Now here's the thing. I did in the first time give you a negative in the exponent, so that first term's okay. However, in the second term, I did not have any negative or fractional exponents, so we need to rewrite this. We still have our 3/2, but the negative in the exponent puts the x in the bottom, and the 1/2 in the exponent tells me to take the square root. So this would be the answer that I'm looking for. If you rewrote the first term as 6 over x to the 4th, I certainly wouldn't mark that wrong because that is equivalent. But be careful that you do not move the 6 to the denominator because the 6 is not raised to the negative 4. Next up, we want to find the equation of the tangent line. Now that you know the shortcuts, you don't have to do a definition of derivative. So the first thing you're going to do is you're going to find the derivative of f of x. Now f of x is 3x squared plus 6x. That means 2 times 3 is 6. Keep the x. 2 minus 1 is 1, so that's our new exponent, plus the derivative of 6x. The old exponent was 1. 1 times 6 is 6. The new exponent on the x is 0, so we don't need to write it. We know that a tangent line is y minus y1 equals m times x minus x1. We now know that our x value was given to us at 1. Our function value is found by plugging the x value into the original function. So 3 times 1 squared plus 6 times 1. That's 3 plus 6, or 9. Then our slope of the tangent line is found by substituting our x value into the derivative. In other words, 6 times 1 plus 6, or 6 plus 6, which is 12. Now if we do the substitutions, we're going to have y minus our y value is 9 equals our slope is 12 times x minus our x value is 1, and there is the equation of our tangent line. If f of x is 2x cubed minus 4x squared plus 3x minus 1, find f prime of x, which is the first derivative, and f double prime of x, which is the second derivative. And do you know how you find that? It's the derivative of the derivative. Let's write this function where I have a little room. f of x is 2x cubed minus 4x squared plus 3x minus 1. So our first derivative, f prime of x, equals 3 times 2 is 6. Keep the x. 3 minus 1 is 2. Now, 2 times a negative 4 is negative 8. Keep the x. 2 minus 1 is 1. I'm not going to write that. The exponent on this x is 1. 1 times 3 is 3. But when I subtract 1 from that exponent, it's 0. I'm not going to need the x's. And the derivative of negative 1 is 0, so I don't need that. Here is my first derivative. Now my second derivative, f double prime of x, we say that 2 times the 6 is 12. Keep the x. 2 minus 1 is 1, so our new exponent is 1. The derivative of negative 8x is, the exponent is 1. 1 times negative 8 is negative 8. I'm now going to have no x's left, and the derivative of 3 is 0. So our second derivative is simply 12x minus 8. All right, guys, we're going to stop here for today. We did a lot of basic rules, but notice how much algebra that's going to save us instead of having to do the definition of derivative. Yay! All right, guys, have a great day. I'll see you soon.